You know, for the longest time, the way we talked to our computers was pretty simple. A click of a mouse and a tap on a keyboard. But that whole conversation has totally changed. We've gone way beyond the desk, and our tech has developed these incredible new ways to see, hear, and even feel what we want them to do, whether we're on a factory floor, in a recording studio, or just walking down the street. So we're going to dive into how all these alternative inputs got started, and more importantly, where they're taking us next.
Right, this is the big question, isn't it? We're going to take a look at everything from the foundational tech back in the mid-2000s all the way to the AI-powered tools we have today. We'll break down how our devices have literally learned to see, hear, and feel our commands in ways that honestly used to be science fiction. And this isn't just about cool new gadgets. It's about making technology feel more like a natural part of us.
Okay, first up, let's talk about the most intuitive tools we've got, our hands. This first group of devices gives the computer a real sense of touch. We're talking about a level of direct control that a little mouse cursor just can't match. It's all about closing that gap between what we do in the physical world and what happens on the screen.
So we're going to look at three types of hand-based input that you probably already know. But we're going to dig into how they've evolved, from the superfine precision of a digital pen to the simple tap of a touchscreen, and of course, the totally immersive world of game controllers. Each one of these has its own story about how we started demanding more from our tech.
You've seen these everywhere, right? From the old Palm Pilots with their tiny styluses to today's super powerful tablets like an iPad Pro or Microsoft Surface. Pen-based input just means you use a stylus to write right on the screen, creating what's called digital ink, or to point and click with amazing accuracy. It basically turns the pen into a hyper-precise, pressure-sensitive mouse.
But the real magic here, it's all in the software. Back in 2006, handwriting recognition was, well, it was a cool idea, but often clumsy. Today, in an app like Notability or GoodNotes, it can analyze your messy handwriting in real time and turn it into searchable digital text, almost perfectly. And it's not just that. Modern styluses can detect pressure and tilt, letting you do some amazing digital art that was just impossible a decade ago.
Next up, the touchscreen. This is the one that has become pretty much universal since the smartphone took over. The idea behind it is brilliant and simple. There's a grid of sensors over the display, and when your finger touches it, it instantly figures out the exact XY coordinate of that touch and registers the command. But the tech that makes this work has gone through a huge change.
And this is exactly why they're perfect for the real world. Early touchscreens, like on an ATM from 2006, were often resistive. You actually had to press down on them. But today's screens are capacitive. They detect the electricity from your skin, which allows for a much lighter touch, more accuracy, and of course multi-touch gestures like pinch to zoom. They're amazing in public spaces or messy places like airport check-in kiosks or industrial controls because they're tough, easy to clean, and they save a ton of space.
And we absolutely cannot forget game controllers. I mean, we've come a long, long way from the old Atari joystick. Modern gamepads are built for one thing: immersion. Just look at the PlayStation 5's DualSense controller. It doesn't just vibrate. It uses this incredibly sophisticated haptic feedback and adaptive triggers to make you feel the tension in a bowstring or the gritty resistance of driving through mud. It's all about making you feel the game.
All right, so we've given computers a sense of touch. Now, let's give them eyes. This next set of devices uses light to read and interpret information straight from the physical world, turning things like patterns, text, and images into data the computer can actually use.
The absolute classic example here is the barcode reader. You've seen it at every checkout counter for decades. Its job is to read that pattern of black and white lines, the universal product code, and turn it into a number instantly. But think about how that's evolved. Back in 2006, you needed a special laser scanner just for that. Today, the camera in your smartphone can scan barcodes and complex QR codes in a split second, connecting you straight to websites, payments, whatever. And the process itself is unbelievably simple and fast. The device shoots a light at the code, the white spaces reflect a lot of light, and the black bars absorb it. A sensor reads that unique pattern of reflections, turns it into a number, and bam! The computer looks up that number in its database to find the product or follow the link. It's just a beautifully efficient way to connect the physical thing to digital information.
An image scanner is pretty similar to a barcode reader in that it also uses light, but its job is much bigger. It digitizes the real world. It can take a printed document, a photo, a drawing, and turn it into a digital file you can save and edit on your computer. And this tech has also been totally transformed by our phones.
So here's how it works. A bright light moves across the image, and as it does, sensors measure exactly how much light reflects back from each tiny point. If it's a color scanner, filters help those sensors figure out the exact shades to create a perfect digital copy. In the 2000s, this meant you needed a big, noisy flatbed scanner. Today, amazing apps like Adobe Scan use your phone's camera to do the exact same thing, and they even have AI that automatically fixes the perspective and lighting for you.
But what if you don't just want a picture of a page? What if you want to actually edit the text on it? Well, that's where optical character recognition, or OCR, comes in. This is the software wizardry that looks at a flat image of words and turns it into a real document you can work with. It's one of the most useful forms of machine vision out there.
And this is the key difference. A normal scan is just a picture. You can look at it, but you can't select a word or fix a typo. But after OCR does its thing, that image becomes real, editable text. Now you can copy-paste, you can search for keywords. It basically unlocks all the information that was trapped on billions of physical pages.
Now, for a long time, this was the big problem. Early OCR was just trying to match shapes, and it would get tripped up by weird fonts or a bad scan. But modern, AI-powered OCR, like what's inside Google Lens, uses machine learning to get incredibly close to 100% accuracy. It can even read handwriting, understand the context of a sentence, and translate text in real time right through your camera. It's amazing.
All right, for our last section, we're going to combine the senses. These audio-visual devices give computers the ability to both see and hear, and this opens the door to some of the most powerful and, frankly, futuristic ways we interact with our technology, moving us away from just clicking buttons to having actual conversations.
We'll look at 3 key pieces of tech here: how microphones and speech recognition give computers an ear, how the MIDI standard gives them a sense of music, and how the digital camera gives them a perfect visual memory. Each one of these has completely changed entire industries.
So speech recognition is basically teaching a computer how to listen. The software breaks your voice down into the smallest units of sound. They're called phonemes. In the past, with software like Dragon Naturally Speaking, you had to spend hours training it to recognize your specific voice. But today's AI assistants like Siri, Alexa, or Grok's voice mode, they use neural networks to understand natural language right out of the box. You can just start talking to dictate a message or control your smart home.
You ever wonder how a musician can play a keyboard and the notes just magically appear on their computer screen? That's MIDI. It was actually invented way back in the 80s, and here's the key. It's a communication language, not an audio recording. It just tells the computer which note you played, how hard you pressed it, and for how long. It's really the foundation of all modern music production.
And this gives musicians an unbelievable amount of creative freedom. With a simple MIDI keyboard plugged into software like Ableton Live, they can compose huge, complex songs, fix one wrong note without having to re-record everything, and layer dozens of different virtual instruments to create a professional-sounding track, all from one computer. It totally democratized making music.
And finally, the digital camera. It completely revolutionized photography by capturing images with electronic sensors instead of old-school chemical film. The pictures get stored as digital files on a memory card that you can use over and over, ready to be edited and shared in an instant. This single shift is why almost every single person has a high-quality camera right in their pocket.
So why does any of this matter? Well, these alternative inputs aren't just neat tricks. Speech recognition makes technology usable for people with physical disabilities. Tough touchscreens make computers versatile enough to go anywhere, and smart scanners and cameras connect our devices so much deeper into our world, closing the gap between physical objects and digital data.
So from the simple pressure of a stylus, to the reflection of light, to the sound of our own voice, we've given our machines powerful new senses to understand us. And it all leads to this one really fascinating question. As our physical and digital worlds keep merging, and as AI gets even smarter, what's going to be the next revolutionary way we talk to our technology?